Hey, good evening, Red Devils chemists. How you doing? It's Coach Scott, and I thought I wanted to. Figured I would go over worksheet 6A with you guys and really review gas laws because we're getting kind of ready to come up on that little assessment thing, otherwise known as a test. So anyway, let's talk. Let me get this little zoom thing out of the way. Oh, there it is. All right, here we go. So, which gas law relates volume and pressure? And a hint I'll give you about gas laws is to identify the one that you're working with, or the best way to identify the one that you're going to work with is find the expression or the variable that's held constant. All right, if you're talking about Boyle's or Charles or what have you. So let's look at this one. So it says, which gas law relates volume and pressure? Express the law mathematically. So I've got pressure and volume. And what the law states is that pressure is an inverse relationship. So as pressure goes up, volume is going to go down. Pressure goes up, volume is going to go down. So pressure times volume equals a constant. Or we can say it PV equals PV, and we can put 1 and 2 there just to show us there's a change in pressure or volume that the other one will go down. All right, and this is called Boyle's law. Boyle's law. Okay, so let's work some of those problems in the Boyle's law. All right, so another little hint I'll give you is as you read the problem, and half of these word problems, the problem or the issue that you have with there is identifying which is the variable that goes with what. So let's look at this. Calculate the new pressure if a 2.4 liter, so I'm going to put a volume down here, right? And then I'm going to go ahead and put 2.45 liters of gas at a pressure of 1, okay, there's a pressure. Pressure equals 1.01 atmospheres. Is contracted to a volume of 2.29 liters. 2.29 liters. All right, and it's asking for the new pressure. All right, so I don't know that. So I'm going to go ahead and label these. This would be V1, this would be P1, because they were together as they came about, right? And we can call this V2 and P2. Now, we know from this expression what Boyle's law is. Let's go ahead and write that down. If you saw what I did here is I placed the right variable with the beginning or the end of what I was looking at, right? And that's half the battle. So P1 V1 equal P2 V2. Use different colors only because it looks pretty. Now I just got to sub in and do my thing. All right, so pressure 1 is 1.01 atmospheres times 2.45 liters of gas. And I'm putting my units in, and you'll see why here in just a minute. And we don't know pressure 1 or pressure 2. Should be 2. We don't know pressure 2, so I'm just going to say pressure 2. Right? And our volume, our new volume, was 2.29 liters. Now, we're trying to solve for the unknown, or pressure 2. So how would I do that? I know, because I took 7th grade algebra. So this is my unknown right there. If I want to get it by itself. So if I divide both expressions by this V2, all right, I'm going to cancel that out. 2.29 divided by itself is 1. But if I do it on that side, I've got to do it on this side. So I'm going to take 2.29 liters, right? Now we can use a little bit of a dimensional analysis. I can cancel out that unit. So liters is gone, and the only unit I have left is atmospheres. Now all I've got to do is do my math, and this is arithmetic. 1.01 times 2.45 divided by 2.29 will give me 1.08, and everything's in three significant figures, so I would write that down as 1.08 atmospheres. So pressure 2 is 1.08 atmospheres. It's not really that hard, okay? Now let's look at this one. Calculate the new volume. It wants to know a volume. If a 13.3 liter, let's go ahead and write that down, B. All right, we'll write the new pressure down because I know I'm going to have some things change. Oh, this is a very interesting one because I got to do some conversions. So the initial pressure, okay, the initial volume is 13.3 liters. And the initial pressure was 2.51 atmospheres. 2.51 atmospheres. And it wants to know what the new volume is. So I don't know that new volume. Question mark. All right. And there was an increase in pressure equivalent to 65 millimeters of mercury. Let's read that expression. There was an increase in pressure equivalent to 65 millimeters of mercury. So the pressure increased by 65 millimeters of mercury. So before I can do anything, I've got to change millimeters of mercury to atmospheres. And then what happened, that pressure at 2.51 atmospheres increased the equivalent to 65 millimeters of mercury. So I've got to convert 65 millimeters of mercury to atmospheres. Let's go over here. 65.0 millimeters of mercury. And if we recall, one atmosphere, and this is how I do all my conversions, one atmosphere, and I put that in the numerator because that's what I want, is equal to 760 millimeters of mercury. Again, if I cancel out my units, millimeters of mercury. All right, so if I've got 65, y'all see it, 65 millimeters of mercury. Ooh, that looks terrible, but y'all see what I said. 65 divided by 760, and that should be a small number. And it is, it's 0.0855 atmospheres. So that's the change, or the delta P, if you would. So the pressure increased from 2.51 atmospheres by a factor of 0.0855 atmospheres. So if I take 2.51 atmospheres and I add it, atmospheres, to this, I'm going to get 2.5955 atmospheres. So that's what our new pressure is going to be, 2.5955 atmospheres, because I changed by that factor, right? That's the delta, that's the difference, and it increased. So I've increased my pressure by a little bit, really, 2.51 atmospheres to 2.59 atmospheres. Since it's an inverse, pressure increased, what should volume do? If pressure increases, volume should decrease because it's an inverse relationship. Okay, let's see if that's going to be correct, or if that hypothesis is going to be correct. So I have what? P1 V1 equal P2 V2. My first pressure is 2.51 atmospheres. And I'm going to multiply that by 13.3 liters. Okay, and I know my new pressure, 2.59. At 5, for heck, we'll put that in there. And I don't know V2. So again, I know basic algebra, basic arithmetic really. So if I want to get V by itself, if I divide it by itself, I'm going to get 1. And if I do that side, I've got to do this side. 2.5955. So now if I got 2.51 times 13.3 divided by 2.5955, I get 12.9. Actually, I got 12.86 something. But if you notice, I've got 3 sig figs, so I only have to have 3 digits. So I'm going to report my answer, and I'm going to come down here and report it, would be volume 2 would decrease, which it should. Volume 2 decreases to 12.9 liters. It started at 13.3 liters. Pressure increased. Volume should go down, and it did. 12.9 atmospheres. All right, so that pretty much covers Boyle's Law, guys, and that's a pretty good worksheet. If you have need more problems, I've got more problems for you, but I think you'll be fine with this. Okay, guys, this is Coach Scott, all you Germantown Red Devil chemists. Peace out.